Hello everybody, hope you're doing well. Sorry we're doing this. My hand is injured, so I'm trying to make the smaller videos. I started with this thinking that I started with a video, but I noticed I didn't. So here I'm starting all over again. We are working on section 10.4 today. Calculus in polar coordinates. So we're going to be using calculus to find the areas, arc length, and tangents involving polar curves. So if you know, we have the area of a sector of a circle. What is the area of a sector of a circle? You've seen it in trig. The area is 1/2 r squared theta, where theta is a central angle. Theta is measured in radian measure. Okay, so we'll be using this in order to find the area of the polar region R. So we have a region R here, and this is right here, is R equal F theta. Our region R is bounded by R equal F theta and the two rays, theta equal A here and theta equal B here. So this one right here is A and this whole thing is B. Now if we want the angle in between here, that would be B minus A, right? This would be B minus A in red. So F is a positive continuous function. B minus A here is between 0 and 2 pi. If we go ahead and divide the interval AB into subintervals, into n subintervals, with endpoint theta 0, theta 1, all the way to theta n. Okay, and they all have an equal width of delta theta. Delta theta here, I'm using the ith interval. Delta theta is a difference between theta I minus theta I minus 1. That's delta theta. Now, if we choose a particular point, some point in there, delta I theta in the I interval, I would love to graph it, but because of the difficulty of me graphing it, but you know, delta I theta would be, I theta star would be in this interval right here. Then the area is delta AI is the ith region. Delta A of the ith region. We can approximate it by using the area of a sector, just like we did here. So how do we do this? Delta AI is approximately 1/2 r squared theta. R is F theta. So we have what? So we have F theta. I'm using I star as a point in the subinterval. Delta theta. So this is an approximation of the area of the ith interval. Now, an approximation of the total area in here would be what? So what do we have? Approximately what? The sum of all the subintervals, the areas of the subintervals. So the sum of all the areas of the subintervals, 1/2 f theta I star square. Oops, I forgot the square here. Remember, it's r square, and r is f theta, so f theta square. We use theta I star. That's our sample point. So 1/2 of theta I star square delta theta, I going from 1 to n. So this is the approximation of the total area. That's the summation of all the areas of the subintervals. Okay? Again, this is the area with central angle delta theta, right? And R is this. All right. So this is an approximation of the total area. Now, obviously, the approximation improves as n approaches infinity, as we've seen in the past. You know, the sums, Riemann sums, right? So if we take the limit of the sum right here, 1/2 f theta I star square delta theta as I going from 1 to n and n approaches infinity, then what is this going to give us? It's going to give us the area, using the integral here, AB 1/2 f theta square d theta. So the total area of the polar region A is or the formula of the area A equal integral from A to B of 1/2 f theta square d theta. We often write it, this is often written as AB 1/2 r square d theta. Remember, r is equal f theta. Okay, so this is the area right here. Now let's see if we can find an example in the book. We can do that. A number that we can do here is, for instance, number 1. If you can open it, if you have the actual textbook, it's on page 699, or you can check it online. Find the area of the region that is bounded by the given curve and lies in the specified sector. So number 1 here. So find the area of the regions bounded by the curve. The curve is r equal square root of 2 theta. And theta is between 0 and pi over 2. How do we find the area bounded by this curve and that lies in the given sector? Well, the area would be what? Using the formula, what do we have? A equal the integral from A to B 1/2 r square d theta, right? We just found it right here. the first page, 1/2 r squared theta. So now we have a and b. So this is the integral from 0 to pi, to pi over 2 of 1/2 r squared. 1/2 r squared, r is square root of 2 theta square d theta. Now this gives us what? It's the integral from 0 to pi over 2, 1/2, the square cancels the square root, what comes out 2 theta d theta. The 2 cancels out, and you have the area is the integral from 0 to pi over 2 theta d theta. If you notice, this is an easy integration. You are integrating with respect to theta. Theta to the 1, that's 1/2 theta square. And this is going from 0 to pi over 2. You can pull out the 1/2. It's not going to change, right? So 1/2. Or you don't have to. This is theta is pi over 2 square minus 0. So we don't have to count this. What does that give us? Theta square. 2 square is 4. 4 times 2 is 8. So pi square over 8. If at any point I'm moving fast, please stop the video and you can go over it. So this is number 1. Okay, so we can do more problems. Let's see, we can do number 4. Number 4, it's the same question. R equal 1 over theta, and theta is between pi over 2 and 2 pi. So let's find the area of the region that's bounded by this curve on the specified sector. So again, we'll be using the same integral here. The area is the integral from pi over 2 to 2 pi. That's what we have here. 1/2 r squared d theta. 1/2 r squared d theta. And then what does that give us? Pi over 2 to 2 pi. 1/2 r squared is 1 over theta squared d theta. The integral of pi over 2, from pi over 2 to 2 pi, 1/2, that's 1 over theta squared d theta. Okay, so you can, if you want, pull out the 1/2, you take it to the numerator. What does that give us here? That's 1/2, the integral from pi over 2 to 2 pi, and you take it to the top theta to the -2 d theta, and that is 1/2. -2 plus 1 is -1 over -1, and just going from pi over 2 to 2 pi, which is the same as 1/2. I don't know if you want to do this, but write it as -1 over theta from pi over 2 to 2 pi. So go ahead and simplify this. What does that give you? So 1/2 -1 over 2 pi minus, so we're going to have a plus 1 over pi over 2. So remember, we have a negative here, so negative minus a negative, that becomes a positive. So simplifying this further, what does that give us? So you flip this, plus 2 over pi. And you can make this 4 over 2 pi. So you can add this. So this is 4 over 2 pi, remember the LCD. So times 2 times 2, that's 4 over 2 pi. 4 minus 1 is negative 3 over 2 pi, negative 3 over 4 pi. Oh, but we don't, oh, that we have a minus, so never mind. So 2 pi, that's 4 pi minus 1. That's positive 3, sorry. So here, remember, times 2 times 2, so we have the LCD, 2 pi. And here, 2 times 2 is 4, 4 minus 1 is 3. 3 over 2 pi times 2, 3 over 4 pi. So that is your answer. Number 4. Okay, so now we're going to be doing number 5. Number 5 has a graph. Please pull out the graph, whether you have the actual book or if you have the online. You need to see the graph from number 5. Okay? I cannot show you the graph and create the video at the same time. The graph is really this. I can quickly graph it like this, but here you have, and this is r square equal sine 2 theta, and shaded this area. So now find the area of the shaded region. So we need to find the area of the shaded region. How do we do that? Well, we already know r squared to be sine 2 theta, and we already know where the region is, the sector, right? So it's going from 0 to pi over 2, right? From 0 to pi over 2. So the area then becomes the integral from 0 to pi over 2 of 1/2 r squared d theta. Now this is already a squared, so it's good. We can just write it as is. We have here 1/2 r squared, that's sine 2 theta d theta. Now we can easily integrate this. What would that give us? Well, you can pull out the 1/2. What is the integral of sine 2 theta? Sine 2 theta is negative, right? 1 over 2 cosine 2 theta, 0 to pi over 2. Right, remember the derivative of this is this, the derivative of this. Derivative of cosine is minus sine. Then you can easily check this. The derivative of cosine is minus sine, but you have a negative, right? So it becomes sine 2 theta times 2, and there you have the 1/2. So it's 1/2, negative 1/2 cosine 2 theta. You could have also included this here. That would have been negative 1/4 cosine 2 theta, and theta going from 0 to pi over 2. So now it's, actually we can pull out the negative 1/2, so it give us negative 1/4, right? We pull it out, and that will give me cosine 2 times pi over 2. What's 2 times pi over 2? 2 times pi over 2 is pi, minus cosine 2 times 0 is 0. We already know that cosine pi is negative 1. So that's negative 1/4. That's negative 1 minus cosine 0 is 1. So that gives us negative 2 Negative 1/4 times negative 2 becomes positive 2/4, that's 1/2. Or A is 1/2. Okay. So if you need more time, you can stop the video and see if you can get the same answer. So let's go ahead and try to do other problems. Let's see. So let's go ahead, if you want, we can do let's go ahead and do number I was going to do number 8, but it's going to be we can do number 8. Take a look at number 8. So let's see. Please take a look at number 8. And the number 8, they've given us the graph looks like this. So this is the shaded region. And they've given us R to be square root of ln theta, and 1 theta is between 1 and 2 pi. So we already have R. Now we can find the area of the shaded region. The area is the integral. They've given it to us from 1 to 2 pi. 1/2 R square. So R square would be square root of ln theta square d theta, which is the integral from 1 to 2 pi of 1/2 ln theta d theta. Now if you take a look, ln theta here, we take the integral of ln theta. To find the integral, you need to integrate by parts. So u would be ln theta, and dv would be, we can do 1/2 d theta. So du is 1 over theta d theta, and v is 1/2 theta. Okay, so that gives us what? uv minus integral v du, right? uv, that's 1/2 theta ln theta, right? uv, I put this one first, 1/2 theta ln theta, minus integral v du. So 1/2 theta times du, 1 over theta d theta. And this is going to work out nicely. You have here 1/2 d theta. So this is already integrated. It's going from 1 to 2 pi. And this is also from 1 to 2 pi. Okay, so if you can see, it's easy to integrate the second one here. So let's go ahead and do this one. This is going to be 1/2 times 2 pi ln 2 pi minus 1/2. This is 1 ln 1. You guys know what ln 1 equal to, right? Okay, minus, let's do this one. So what do we get here? The integral of 1/2 d theta, that gives us what? 1/2 theta, right? 1/2 theta from 1 to 2 pi. ln 1 is simply 0. And now let's go ahead, this cancels this. So you have pi ln 2 pi. So pi ln 2 pi, this disappears, minus here 2 pi over 2, that's a pi, right? 2 pi here, and the 2 cancel with the 2, minus 1/2. So that gives us, that's pi ln 2 pi minus pi plus 1/2. So this is number 8. Okay. So we can do also one example where we can graph it ourselves. So we can do number we can do number 9. Number 9, that is r equal 4 cosine theta. Okay, hi everybody, we're doing number 9. I just paused the video a little bit to graph this. It take me a little while to graph it. So we're gonna go ahead and graph this. Now when theta is 0, cosine 0 is 1, I mean r is 4. So here's 4 and x it's 4, 0. R is 4, theta is 0. Now when so you can, if you want to, write it down here, sorry, theta and r. When theta is 0, cosine 0 is 1. 1 times 4 is 4. So that's what you have here. 4, 0, r theta. Okay? When theta is, if we use pi over 4, what are you going to have? Cosine pi over 4, if I write it down here, 4 times cosine pi over 4. Cosine pi over 4 is root 2 over 2. So this is going to cancel out. You're going to have 2 square root of 2 over 2. If you plug it in the calculator, so this is 2 square root of 2. Plug it into calculator, it's going to be like 2.8 something. So pi over 4 is here, right in the middle. And 2.82, so 1, 2 is roughly around here. Sorry if I try to make it as easy as I can here. So this point right here, r would be 2 square root of 2 and pi over 4. And now if we go to pi over 2, when theta is pi over 2, cosine pi over 2 is 0. So that point right here is r 0 and the angle pi over 2. Now if you go ahead and choose 3 pi over 4, 3 pi over 4 is here. Now if you remember, like cosine 3 pi over 4 is negative in the second quadrant. So cosine 3 pi over 4 is the same as negative the cosine of pi over 4. So that's going to be the same as this, except it's going to be negative 2 square root of 2. So pi over 4 here, but you have a negative r, so you go in opposite direction. So you're going to go negative 2 square root of 2, so 1, 2, so it's going to be roughly around here. And here we have, if we plug it in, this is a circle. Sorry if it doesn't, this should be here. So this is a circle. All right. and we graphed it ourselves, unlike the ones that are given to us. Now we can easily find the area. What is the area? Well, we know that from here, because they want us to sketch the curve and find the area that encloses. So here we have from the area is bounded by r, which is 4 cosine theta, for theta equals 0 and pi, to 0 equal pi. So that's what we have here. So it's the integral from 0 to pi of 1/2 r squared d theta. So that's the integral from 0 to pi of 1/2 r squared is the square of this, which is 16 cosine square theta d theta. Now simplifying this, what does that give us? It's going to be 8. 16 divided by 2 is 8. I can leave the 8 out. From 0 to pi of 16 of cosine square theta d theta. Now cosine square theta, we want to write it as a not a square. We want to use what, reduction formula. The cosine square theta from trigonometry, if you remember, is 1/2 1 plus cosine double the angle 2 theta d theta. So this is from trigonometry. And now let's go ahead and simplify it. If you pull out the 1/2, you get 8 divided by 2, that's a 4. And this 1 d theta, that's d theta, which integrate as theta, plus the integral cosine 2 theta is 1/2 sine 2 theta, right? So it's going from 0 to pi. Okay, and let's see. Sine 2 pi is going to be 0. Oh, this is going to be 0 in both of them. So this is the same as 4 pi plus 0 minus 0 plus 0. So it's going to be just 4 pi. Okay? By the way, we didn't do a third one here. If you consider pi, cosine pi is -1, that's -4. So pi here, if you go pi here, -4, it comes back here. Comes back to our original. So from 0 to pi, sorry, I forgot. I didn't do that last one. That's why we have 0 to pi here. From 0, we went from 0 to pi over 4, pi over 2, 3 pi over 4. When we go to pi, cosine pi is in, here's pi, but r is -4, so it's in opposite direction, so it comes back to the circle, to the origin, to the first point. So we started here, we came back here. So that's from 0 to pi. So this is number 9. Okay? Okay, so now we're gonna start with arc length. And now if we remember from 10.3, we use the equation to go from polar to rectangular coordinates. If you recall, from x, y to r theta, we used the following equation: x is equal r cosine theta, y equal r sine theta. You also seen that in trigonometry. So if we take this x equal r cosine theta, now we know r is equal to f theta, right? R equal f theta, so f theta cosine theta, and then here y equal r sine theta, and that is f theta sine theta. So we need to find the length of the polar curve r equal f theta, theta between a and b. So we're going to differentiate with respect to theta. We're going to be using obviously the product rule. So taking this, dx d theta would be what? Dr d theta cosine theta, right? Plus r, the derivative of cosine, minus sine theta. We are using the product rule. Derivative of the first times the second plus the first times the derivative of the second. So that's the same as dr d theta cosine theta minus r sine theta. Now we're going to be doing the same thing with y. dy d theta is dr d theta sine theta, okay, plus r cosine theta, right? Now if we add the square to both of them, so what do we have? We have, if we take dx over d theta squared, you add to it dy over d theta square, what is that going to give you? So square this, right? So it will be dr over d theta square times cosine square theta. Remember, we are taking the square of this. Now remember from algebra, a minus b squared is a squared minus 2ab plus b squared. So this one squared minus 2 times this times this. So minus 2 times r dr d theta cosine theta sine theta. So 2 times this, plus b squared plus this one square, so plus r squared sine square theta. So this is the square of the first one right here. I'm going to add to it the square of that. So what would that give me? The square of this is the square of this here, applying the same rule, but now you have plus and plus here. So this one squared sine square plus 2 r dr d theta cosine theta sine theta, or sine theta cosine theta, plus r square cosine square theta. Now take take a look here. What are we going to have? We got excuse me. Take a look at these two. If I were to factor out dr over d theta square, we're going to have here cosine square theta plus sine square theta. This is going to help us. Why? Remember in trig, cosine square theta plus sine square theta is 1. So it's going to be 1. Okay, and now look at this here. It's the same. 2r d theta sine here, cosine here, opposite sign. They cancel out. Here, if I were to factor the r square, so what am I going to have? R square is sine square theta plus cosine square theta. So that works out nicely. This is a 1 and this is a 1. 1 times dr d theta square is dr d theta square plus r square. Okay, so what do we have? So assuming f prime is continuous, okay, we can use the theorem to write the arc length. So L would be what? The arc length L is the integral from a to b of square root of dx over d theta square plus dy over d theta square d theta. We can rewrite it with polar equation r equal f theta. So with polar equation r equal f theta, a theta is between a and b, so what does this become? L would be equal to integral from a to b square root of, so r square plus dr over d theta square d theta. Okay, so this is the arc length. L equal the integral from a to b square root of r square dr d theta square d theta. Okay, so let's go ahead and use some example from the book. So let's go ahead and do number 49. Please open your book on number 49. In number 49, they're asking, find the exact length of the polar curve. Find the exact length of the polar curve. So it is r equal to cosine theta. So let's go ahead and find the exact length. So we have L is, we just seen it, the integral from a to b, right, of square root of r square plus dr d theta square d theta. So we just seen it right now, r square plus dr d theta square d theta. Okay, so that's what we have. Now, by the way, I forgot to write it down. Theta is between 0 and pi. That's the question here. So that is the integral from 0 to pi square root of r squared, so this one squared, that will give us what? That will give us, if you want me, I can do it next time too. R squared, I'll just write it as is now, plus dr d theta. What is dr d theta? Let me write it down here. So dr d theta is what? The derivative of cosine is negative sine. So negative 2 sine theta, right? So dr d theta is negative 2 sine theta. And it's squared. Oops, running out of space. This is d theta. Okay, so that will give me what? This is equal to the integral from 0 to pi square root of, that's 4 cosine squared theta, 4 cosine squared theta. So this becomes 4 sine squared theta plus 4 sine squared theta. And what do you notice here? You can factor out the 4 from here. What are you going to have? if we factor the 4 from the square root, right, what would that give you? Cosine square theta plus sine square theta, and here d theta, isn't that 1? That's equal to 1. So that's the integral from 0 to pi of square root of 4 d theta, which is the integral of 2 theta going from 0 to pi, and that is equal to 2 theta from 0 to pi. So that's 2 pi, isn't it? Pi minus 0, 2 pi. Okay? That is the exact length of the polar curve, 2 pi. Well, if you notice, this is isn't that a circle of radius 1, right? What is the circumference of a circle? 2 pi r, so 2 pi times 1, there it is. So that will confirm that as well. Yeah, the curve is a circle of radius 1. Okay, so this is number 49. Find the exact value. Let's do a couple of more problems, so make sure that you guys get it. Let's see, we can do number let's do number 51. Same question. R equal theta square, and theta is between 0 and 2 pi, right? So let's see, they want us to find the exact length of the polar curve. No problem. What is it? L remains a. L is the integral from a to b, square root of r square plus dr d theta square d theta. So that gives us what? That is the integral from 0 to 2 pi. They told us theta is from 0 to 2 pi. Square root of r squared, that's theta square, right? Plus dr d theta. What is dr d theta? Dr d theta on the side, that's what? That is 2 theta, isn't it? So dr d theta square, so 2 theta square d theta. So that is the integral from 0 to 2 pi of theta to the 4th power plus 4 theta square d theta. Now we're going to have to do a little bit of maneuvering here. We're going to try to work this out here. So 0 to 2 pi, what do you notice? First of all, we can factor out theta square. Inside the radical, you get theta square plus 4, right? So there you have one thing that will come out as theta. So that will give us the integral from 0 to 2 pi theta square root of theta squared plus 4 d theta. Okay. So you want to try to see if you can have this work. Use U substitution. I think U substitution would work. If we let U equal to theta squared plus 4, du would be what? Would be 2 theta d theta. We already have theta d theta. You don't have to worry about the 1/2. So 1/2 du is theta d theta. So there we can change this to u, so then you have, this is u to the 1/2, right? Square root of u, that's u to the 1/2, right? Theta d theta is 1/2 du. We just need to change the limits of integration. So let's see, when theta is 0, u is 4. 0, that's u is 4. When theta is 2 pi, that's 2 pi square, or 4 pi square plus 4. So this is 4 pi square plus 4. You see that? So 2 pi squared, that's 4 pi square plus 4. And now you can easily integrate this, right? And what does that give us? That's 1/2, you can pull it out. 1/2 plus 1, that's u to the 3/2 divided by 3/2 multiplied by 2/3, right? From 4 to 4 pi square plus 4. You can pull out the 2/3, right? 1/2, 2/3, so this and this cancel out. So you're left with what? 1/3, right? And that is 4 to the 3/2, so take this to the 3/2. 4 pi square plus 4 to the 3/2 minus 4 to the 3/2. Okay. There's an option also to factor out the 4 from here. So it would be 4, and we had 4 here. So let's go ahead and try to do this. Another page. So you have the option, you could continue what we done. So continue from number 51. So what does that give us? We have 1/3 u to the 3/2. So 4 pi plus 4, that's 4 pi square plus 1. This is going to come in handy because we have them both like that, right? So this becomes 1/3 4 to the 3/2 times pi square plus 1 3/2 minus 4 to the 3/2. So this is as far as the algebra part that's going to work out. So you can factor out the 4 3/2, right? Or you know what this 4 3/2 from algebra, what is that? Square root of 4 to the third power. So this is 2 cubed, that's 8, right? So this is 8. So this becomes 8, and this is 8. I can factor out 8. I can pull it outside. So this is 8 right here. And you are left with what in here? Pi square plus 1 to the 3/2 minus 1. And this is your exact answer. So this is number 51. If you need to stop the video for a minute and go over this, please do so. Okay? So this is number 51. There are no problems where you can find the length of the curve correct to 4 decimal places, so it won't be exact like this. You're just going to have to use your calculator to get the answer.